So in this today's class, we will be talking about tautology, contradiction, and contingency. So basically, what is tautology is a compound proposition that is always true for all possible truth values. That is, whenever you have a truth table, all the values that you will be having is truths. That is called tautology. What is a contradiction? A compound proposition that is always false for all possible values. Like instead of this TT, you'll be having FF, and instead of this TTTT, you'll be having FFFF. That is contradiction. Now coming to contingency, like what if you have multiple truths and multiple false in a statement? So a compound proposition which is neither tautology nor contradiction. That is, it will not be all truths or not all false. That is, you'll have multiple number of truths and multiple number of false. That is called contingency. Okay. Now quickly moving on to the other truth table. This one we have to show whether this is tautology or not. So the question says, if P implies Q. I hope you all remember the definitions of negation, contradiction, contingency, disjunction, and biconditional. Okay, so P implies Q and Q implies R. P implies Q and Q implies R. This implies P implies R. So we got to find a truth table for this. I do not know whether it is tautology, contingency, or contradiction. We'll just look into the truth table and find whether it is tautology or not. So P, Q, we'll just write a bit, near so that we'll have all the values. P, Q, R. We are talking about P, Q, and R. So there are no negations in this. So you don't have to take any negations. But the thing is, there are implications. So you got to take P implies Q, Q implies R, and P implies R. Okay, P implies R. P implies R will take a bit later because there is a relation between P implies Q and Q implies R. So what is that? P implies Q and Q implies R. Okay, and then what are we talking about? This one, the right hand part. That is P implies R. Now, what is the entire question? That is this and this one. So, what is that? P implies Q and Q implies R. And then what is that we have in the between? By conditional. Conditional P implies Q. What are the conditions that you have to learn? One is or. What is or? If both are false, then only it is false. Otherwise, it is true. What is and? If one is true, one is false, then it is false. Otherwise, it is true. And then you have conditional. What is conditional? Oh, sorry. This is if you have two truths, then it is true. Otherwise, it is false. Contradiction. And then contingency, if P is true, Q is false, then it is false. Otherwise, it is true. That's it. We are just talking about these three conditions. So make sure that you know what is disjunction, conjunction, and conditional. Now, as we are talking about P, Q, and R, what is that we have to take? We got to take all 4 truths and 4 false. So true, 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 and false, 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 and false. As we are talking about Q, P, Q, R, there are 3 prepositions. We got to talk about 4 truths and 4 false. Now coming to Q, what will be like? You'll be having 2 truths, 2 false. That is true, true, false, false, true, true, and false, false. Am I clear till here? What is our alternative truths and false? So true, false, true, false, true, false, and true, false. Okay, I'll write this in a single line so that it will not be a bit confusing to us. So what is this? 4 truths. This will be false, this will be false, and this will be false. This will be alternative truth. So this is true, false, and false. And this is true, false, true, false. I hope you can see this line so that you'll not get any confusion between those. Now coming to conditional. What is conditional? If P is true, Q is false, then only it is false. Otherwise, it is true. So we'll just mark this. What is that? If P is true, Q is false, then only it is false. If P is true, Q is false, then only it is false. This is true, this is false, then only it is false. And then that's it, right? So rest of the elements are truths itself. So this is true, this is true, 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 and true. coming to Q and R. So going to Q and R, what is Q and R? True, this is true, this is false. So this will be false. And then this is true, this is false. Then so this will be false. And then the rest of the elements will be true. So true, 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 and this is also true, and this is true. Now coming to and condition between this one and this one. What is conjunction? Whenever you have two truths, then it is true, otherwise it is false. Now search wherever you have truths. Here it is true, true, so this will be true. Again, where here you have two truths, so this will be true. Again, here you have true, so the last two elements will be true, rest of the elements are false. So this is F, this is F, this is F, and this is also F. That's it, right? Am I clear till here? Next coming to PR. So this one and this one. Now what is that implies? If P is true and R is false, then only it is false, otherwise it is true. So I'll just make a circle. If P is true, R is false, then only it is false, otherwise it is true. And then here true, false, so this is false, and then that's it. So rest of the elements are truths. So this is true, and here it will be true. Again, this is true, this is true, this is true, and this is true. Now coming to this column and this column. So what is that implies? So same thing we have to do. What is that? If T is true and Q is false, that is, see here there is no true and false. It is true, false. FT is there. You got to find TF. So there is no TF over here. So what is that we can write? We can put all truths. Right. I'll just choose another color so that it will be more easy. Yeah, black. So true, true, true. This is true. This is true. This is true. This is true, and this is true. So as all are truths, what is that we can conclude? We can conclude that the given statement, whatever is there, that is tautology. Tautology. Am I clear? Shall we move on to the next definitions? I hope I'm clear till here. So you just have to remember three conditions in this. What is that? As we are making use of and, conditional. That's it. Yeah, and conditional. There is no or. So there's only two conditions you have to remember. And conditional. Next, moving on to the very, very, very important definitions, that is normal forms. They are normal forms. So till now we have studied about connectives, we have studied about some derivatives, and now we will be studying about normal forms. So there are three types of normal forms. The three types of normal forms are min terms, MIN, min terms, MAX, max terms, and then there is some disjunction normal, disjunction normal form. So what are these normal forms? What is min term? What is max term? What is disjunction? We'll just look into it. So coming to the first definition, that is min terms. What are we actually studying about? Normal forms. Okay. So the definition of min terms is if there are P and Q, two prepositions. There are some P and Q, two prepositions. Then what are the conditions? P and Q. Negation P and Q. P and negation Q. Negation P and negation Q. All these are termed as min terms. Min terms. Okay, we are just talking about P and Q, negation P and Q, P and negation Q, negation P and negation Q. They are all min terms. And P and negation Q, comma, negation P and Q. These are called elementary products. What are these called? These are called elementary products. Yeah, elementary products. These are min terms. Now coming to the definition of max terms. Coming to the definition of max terms. So what are max terms? In the same way, you got to define. What is that? P and Q are two prepositions. Then P or Q, negation P or Q, P or negation Q, and then negation P or negation Q. Okay, or all these are termed as max terms. Max terms. And in the same way, you got to you will be having P or negation Q and P negation P or Q. These are termed as, what are these termed as? Elementary sums. These are elementary products. These are elementary sums. Elementary sums. Okay. Now we have spoke about min terms. We have spoke about max terms. And then now we will be speaking about next. The next definition is disjunction normal form. Disjunction normal form. So what is disjunction normal form? There are three steps which are required to obtain the disjunction normal form through an algebraic manipulation. So there are three steps to solve this. The first step is remove all. Like you got to remove. This is a very important one. So listen carefully. You got to remove all conditionals and biconditionals. What are these? What does this mean? This is conditional. This is biconditional. So remove all conditional and biconditional by equivalent expression. By equivalent expression. You got to remove all those by equivalent expression containing the connectives by using and, or, and negation only. You got to remove conditional and biconditional by using this. Now in the next step, what is that you have to do? In the second step, eliminate negation before sums and products. You got to eliminate negation, that is this one, this symbol, negation before sums and products. Like once we do one example, I think you will be having more clear idea. Okay, by using De Morgan's law. Now here you got to make use of all the laws. So I hope you all know the definition of laws, like all the associative law and etc. etc. So the important law is De Morgan's law. Like the important step that we are going to be using is the only one law, that is De Morgan's law. Okay, and the third step and the final step for this is apply distribution law until sum of elementary products are obtained using step 2. Apply, we got to apply which law? Distributive law. Distributive law. I hope you remember what is De Morgan's law and distributive law. So apply distributive law until the sum of elementary products are obtained by step 2. Okay, the sum of elementary products are obtained by step 2. Okay, now we will be using this one. What is the first step? You got to remove conditional, biconditional by using these three. In the second step, eliminate negation before sums and products. Like if you have any negation before any sum or product, you got to eliminate that and apply distributive law until the sum of elementary products obtained by step 2. Now we'll clearly see what all these terms mean and what they actually wanted to tell. Okay. Now let us just look into one problem. The problem is they are asking disjunction normal form is not unique. What is that they told? This disjunction normal form They're telling that whatever form is there, this is not unique. Disjunction normal form is not unique. So what is this? What are they actually trying to tell? We'll just see that. So in the first, like there is some problem. The first problem. Obtain the disjunction normal form of, I'm just writing DNF, the disjunction normal form. Okay. For P implies Q, for P implies Q and negation Q. So what are the three steps? I hope you made a note of it. The first one is removing conditional and biconditional. The second one is eliminating negation, and the third one is applying distributive law. Now we will do for the following problem. What is the first one? Now we'll just write the question. Consider P implies Q and negation Q. So what is the first step? Taking out conditional and biconditional. So here there is no biconditional, so there is conditional. How should we remove this? By making use of and, or, and negation. So what is P implies Q? There was a law which says P implies Q is negation P or Q. Okay, this is what P implies Q is. P implies Q is negation P or Q, and same thing, negation Q. The first step is completed. Now what is the second step? You got to eliminate this negation by, if there are some sums or products, you got to eliminate in front of them. So what is that we are doing? As there are no sums and products, I'm just writing it, negation Q and negation P or Q. Okay, I'm just writing it like this. Now the next step is, by, like, since I wrote this because from commutative law. Like, what is commutative law? If A equals A into B equals to B into A. So I just made use of that by using commutative law. By using commutative law, I got this step. Now this is something like distributive. So since by distributive law, how can you write this? You can write this as negation Q and negation P, right? Or negation Q and Q. So this is what it is. What is that? Negation, I'm just distributing negation Q and negation P. This is finished. Again, negation Q and negation, negation Q and Q. What is negation P and P? This is a product, right? This is product. This is sum. Again, this is also product. So this implies sum of products. Sum of products. So what are they trying to tell you is, like, disjunction normal form is not unique. That is, you will be getting in such a way that you have some few elements which are not unique. Like, you'll not only get one element, a unique element, you will be having different elements like this. See, you got negation Q and negation P, or negation Q and negation, sorry, and P. Okay. So now let's look into the second one. The second one is, if P, like there, you have to obtain the disjunction normal form for the following thing. P or negation P implies Q, or Q implies negation I. This is a bit, it is a bit kind of stupid stuff, but we'll just make it a easy way. What is the first step? Taking out implications and by implications with respective to what? And, or, and negation. So how many conditionals are there? That is implications. There are two. So by you making use of this, we'll just remove these by implication. So what is that? This is equivalent to P or negation P. So as there is some there is a implication, I am writing this as negation P or Q, or negation Q. This is negation Q or negation R. Okay, Like previously, what is that we wrote? If Q implies P, negation P or Q. So in the same form, you have to write that one. And then in the next step, what is the next step? You got to remove all the negations. So how will you remove all the negations? By using, by making use of this products and sums itself. That is or and this one, or and ands. So what is that you can do? You have to write P or neg. This is negation P or Q, and then you have or negation Q. So now you have to take out the bracket and write P or P or Q. I'm just writing this negation P as P because like P or negation P is P. P or P. I'm just distributing it like this. If you distribute, it will be P or negation P, and then you will be having again or, and you will be having P or Q. So you'll have this all things. So I'm just directly writing it. You'll have P or Q, or this one negation P, negation Q, or negation R. See, I'm just writing this. This is P. Again, P or negation P gives you P. Again, writing Q, taking out the brackets, or negation Q or negation R. Okay. So this will be equivalent to P or Q or negation. Like what is P or P? P or P is equals to P again. So from this you got P, P or Q, or negation Q, this one, or R. Negation R, I'm writing it as R. This is a required sum. This is sum, right? This is sum, this is sum, and this is sum. So this is the required sum of products. The required, sorry, the required sum of products. The required sum of products. Okay. So I'll just give you one homework problem. Just try that and tell me what you actually got. If you do not get that, I'll explain it in the next class. Take a note of this problem. Just try it. Just remove conditionals, and then in the next step, remove negation also, and you will get something in terms of sums and products. So the question is, P implies Q, and negation of negation Q and negation P. So just try this question and let me know in the next class. After this one, you have principal disjunction normal form. I'll just go with the example. 11th, yeah. The next topic is principal disjunction normal form. I will just continue this definition in the next class. Okay.